Good morning, everyone. My name is Logan Lohr. I'm the project manager and structural engineer for G.A.L.S. I'm here to talk to you today about the progress we've made on the Eastgate Development Project. With me today are our transportation engineers, Roberto Alanis and Abraham Steinbeck, as well as our water resources engineer, Brian Gibbons. We're here to present our selected design alternatives as well as our predicted cost estimates for both design and construction costs. So let's jump into the cost estimates for this project. For total design costs across all disciplines, we have predicted design costs of about a little over $100,000. And for our predicted construction costs, we're at just over $15 million. We'll go more into depth on this later on in the presentation. Moving on, like I said, I'm responsible for the structural components of the project. So we have been tasked to design a retail building that has at least 16,000 square feet, as well as a senior living building that has a square footage of at least 20,000 square feet. And we've also been asked to provide a covered outdoor area of at least 2,000 square feet. So to look at, recap our alternatives, this is the senior living facility. As you can see, the second floor is cantilevered slightly, so that's to provide that covered outdoor space. All of the alternatives for this, the structural components of the project remain, they have the same layout, and we consider the different materials for each alternative. And so for the commercial building, here's another render of it. And so we looked into the different materials, like I said. And so for the senior living building, we considered the use of timber, reinforced concrete, and steel. And then for the commercial building, we considered the use of reinforced concrete, steel, and concrete masonry units. All of these alternatives were considered on the basis of cost, environmental sustainability, and ease of construction, with cost being the most heavily weighted factor. So, quick comparison. As you can see, the costs for the senior living building were relatively similar. However, steel was the most economical. In terms of ease of construction, we considered timber and steel to be the most easiest to construct, whereas concrete was considered to be more difficult. Because this is a second-story building, two-story building, there would be associated curing time for concrete, so that's part of the reasoning as to that. And on the environmental side, we considered that timber and steel to be relatively similar, and reinforced concrete to be more economically or environmentally hazardous. Originally, we considered timber to be the best because of its ability to capture and store carbon. However, there aren't any timber distribution facilities nearby Valparaiso near the site, so that would be an associated travel cost where we have to ship that across. And then moving on to the, so we selected the steel alternative for this building. Here is a typical framing plan for the first and second floor. Typical spans range from about 30 to 40 feet based on the areas. In the community area over here, we have slightly longer spans. And then for the commercial building, we considered, like I said, reinforced concrete, steel, and masonry. Again, costs were very similar, however, masonry was slightly more cost-effective. And then we also considered ease of construction and environmental sustainability. In this instance, steel was the most easy for construction. However, because of the associated costs with masonry, we selected masonry as our final alternative. So here's a framing plan for the retail building. All these walls would be load-bearing, and then we will span the shorter distance of each of these units with steel joist girders. For the predicted costs, we considered about 150 hours of work for this project, and this rate factors in overhead as well as other associated costs, coming up to a total of $36,000 for our predicted design costs. And then the senior living building has an associated cost of $5.36 million, and then the retail commercial building had an associated cost of $2.24 million, coming out to about $7.6 million in total. For future work, to model these structures in RISA, and then obviously based on the RISA output, I will select which members will be used, and then I will do some associated hand calculations for specific areas of the building to verify RISA's output, and then I will have to design the corresponding footings for each building. I'll pass it on over to Roberto to talk about the transportation aspects of the project.
Thank you. So, transportation, My name is Roberto. I'm the transportation engineer for the northern portion of the Eastgate development project. Just a quick recap, my scope was to design a road alternative that would safely connect the Sturdy Road and the Silhavy Road at each point while redesigning or designing any new intersections or current intersections. Additionally, I was to develop parking lots, a parking lot or parking lots for the new developments that my structural engineer is to be designing. And additionally, I was to prepare pedestrian facilities along this set alignment. These are design criteria and assumptions: 12-foot lane width, minimum of 30 pavement width from end of the road to the other side, a minimum of 30 curb radius at each intersection, 2% vertical grade, and a minimum of 4 feet for the sidewalk. So I looked at 3 different alternatives for each intersection, three different alternative designs for each intersection. The Sturdy Road intersection, the Silhavy Road intersection, I felt both needed 3 separate designs. I went with a signalized intersection, a roundabout intersection, and a 2-way intersection. On the left, you can see the Sturdy Road intersection. You can tell, as you can see, there is an additional lane that is required for this and 2-way stop, and the northbound and southbound approaches. And here on, I guess you're right, would be the Silhavy intersection. This is the design concept for the roundabout. Again, left is Sturdy, and then right is Silhavy, and then the 2-way stop, each respectively Sturdy and Silhavy. I went to, for the selection of my alternatives, I chose 5 different criteria for the Sturdy Road and 4 different criteria for the Silhavy intersections. Each criteria was weighed on a scale of 1 to 10, depending on subjectively how I felt each intersection would interact with said, which intersection would interact with said criteria, depending on how appropriate it felt for the design, for the project. Each design was graded on a scale of 1 to 5, 5 being as near as perfect as I assumed it could be, and then 1 being the least likely. As we can see here, each alternative was given a ranked total, and by this design, the final alternative was selected to be the highest total here. So in which case, it would, for both intersections, it would be the signalized intersection. This is the final design after careful consideration of last presentation, and a couple minor tweaks for the senior living building, and to my design road alternative. I decided to split the 2 lots, and instead of the one entrance, I went with 2 entrances, as the 2 lanes on each direction would make it much less likely for congestion on this new development. This is my construction cost. After all, it could be estimated that the total rounds up to about $3,500,000. So this is the final design. It can be seen that each entrance to the parking lots has a radius of about 55 feet, and the radius at each intersection is a standard minimum of 30 feet. Yeah. This is my work breakdown structure. This is what I plan to be doing in the future, along with my design cost estimate. Thank you, and I will pass it on to the southern portion of the project. Yep, there you go.
Thank you, Roberto.
Alright.
So my project had to deal with the scope on the southern portion of Eastgate project. So just a little refresher, the scope of it was a whole new realignment to Silhavy. We had to do a whole new intersection, and there had to be a bike path and pedestrian path availability. So with this, a couple of my design elements that I found out and that I used while I'm going over my alternatives were just the traffic flow, the level of service, and vehicle delay time. These played a major part in figuring out which alternative to use based on the safety factors and what the city needed. Moving forward with alternatives, so these were all assumptions. So I used based on AASHTO and with NDOT regulations and with the city regulations as well. 12-foot wide lanes both for the intersection, for the realignment, and for the bike path. The main reason for that is to allow emergency vehicles to get through in case there is an accident that happens. So some constraints. With this, a major part of any roadway construction is the right-of-way. This affects a lot of people. There is farmland out here, so this would have to deal, if an alternative would go through the farmland, we'd have to talk to the city about purchasing this land in order to use it for the alternatives. Another portion of this is the wetland region, which is a huge factor. This is the reason why there is a realignment issue with this road. So in order to go about this, all of these had to be dealt with in order for the cost analysis. Right here are my two alternatives. I have a four-way stop. I also have a signalized intersection. During my cost analysis and through my delay time review and LOS, I figured out that the four-way stop had an LOS of A, level of service of A, level signalized, had a surprising level of service of B. Right here, this is how I rank my alternatives. I use a pretty basic scale of 1 to 10, 1 being the least effective, 10 being the most effective. This was mostly to my opinion and subjectiveness as an engineer, as to what I thought would be best for the city of Valparaiso in order to fit the scope and better the safety of the public. Here I use the traffic capacity, pedestrian safety, aesthetics, how does it look, how's it going to work, the maintenance issues, seeing, all right, remember we're in the Midwest here, it's going to snow, are the plows going to be able to get through, what's it going to look like? From these alternatives in the ranking scale, I was able to figure out that my best bet was going to be the four-way stop. So with this, I decided to go forward with the calculations according to the NDOT specifications using their metric scale. I was able to find out my total cost, which is about $4 million. Right here is the final design for the parking lot, which will be located on the northwest portion of the baseball field. This will be located here. As you can see, it's a one-way entry. It's designed for a WD-50 truck to also get around as well. And with that, there's also 5 handicap spots. This is in specifications and ordinance with city ordinances. That way, if there is handicapped people that want to go to the baseball games, there are spots for them. With this here, this is what the final design will look like. As you can see, those 2 green dots up there, what those are is with the baseball diamond and with the bike path, they allow for information sites to be put in. So I was talking to my technical advisor, Professor Grossman, also in contact with the Valparaiso City. Here, it would be nice to be able to go out with your family and with your friends, not only to see a baseball game, or to see the new construction sites and the structural buildings, but also to get information about the wetland region and also about the history of Eastgate as well. So throughout these information sites, there will be postages about the plants, the animals that are living there and thrive in that community. Right here you can see that in that pink, that there will be removal of that existing pavement. The total realignment will allow access to the 2 hotels that are down there on the southern portion. And the total realignment will end at the Old Lake Road. So for future work, a lot of it has to deal with the geometric design of the CAD drawings, a lot of the title sheets, We got some critical section sheets that will need to be drawn up. This will take most of the time. Line work and then aerials in the background will also be concluded in the future. And now for our water resource engineer, Ryan Gibbons.
Thanks, Ed. So I figured before I talk about my preferred alternative, I'd go back and do a recap of my other alternatives, considering they've changed pretty substantially since the last presentation. So alternative 1 makes use of a rain garden for the water quality line, and that overflows into a detention pond for the flood control line. And the means of transportation for the stormwater would be bioswales. Alternative 2, also use rain gardens, however there's 2. One rain garden will serve the northern end of the site for the building and associated parking lots, and the other rain garden will serve for the parking lot on the southern end of the site. For this system, ditches with vegetated check dams will be used. Every 50 to 100 feet, there will be vegetated strips in the ditch system for pre-treatment before it gets to the rain gardens. And then overflow for the rain gardens will go into another detention pond on this alternative as well. Alternative 3, instead of using rain gardens, I decided to go with a constructed wetland, which overflows into a detention pond, and bioswales are once again used for this alternative to transport stormwater. Alternative 4, similar to alternative 3, there's another constructed wetland. However, this will overflow into underground storage, and the transportation for the stormwater will be with the ditch system with check dams. After I had all my alternatives, it was time to do the analysis. I used a scale of 0 to 10, 0 being the worst score, 10 being the best, and 5 being around that mid-range value. In the flood control analysis, I decided that the detention pond would be the best alternative. I considered retention ponds and underground storage, but they just didn't fit the site. Next, I looked at water quality control measures, and I decided that the rain garden was the best alternative from these measures to use. It just outweighed everything else. Nothing else really made sense for the site except for this. So I went with the rain gardens. And then after that, I looked at the different ditch systems I proposed. I looked at bioswales and ditches with check dams. And I decided that the check dam system would be superior, mostly because of cost. Bioswales have to be completely filled with seeding, and the check dams will have cheaper seeding throughout the there have to be thick seeding at the check dams, but the grassway between the check dams will be much cheaper for seeding than the bioswales that will have the expensive seeding throughout. With all that, I went with alternative 2, considering it had all of those systems at 1 in their specific categories, with the 2 rain gardens, the detention pond, and the ditch system with check dams. Cost estimate. It's going to take around 150 hours to design, and it will be charged at $140 per hour to the client, for a grand total of around $21,000 of design. Construction cost, I got all this pricing from the EPA. They're all high-end pricing, and I used my volumes, areas, and lengths of my preliminary drawings to come up with pricing for each category, added them up, rounded, and it's going to be around $1.2 million. Future work, I'm going to have to take a look at my flood control volume calculations. Building sizing and parking lot sizing has recently changed, so I'm going to have to go back through and make sure all my calculations are right for the impervious area. I have to design all my rain gardens, detention ponds, outflow structures, culverts, and my ditches, and then I also left a little bit of time in there for any reports that need to be written next spring. With that, that concludes our presentation. If anybody has any questions, feel free to ask right now.
Got a question. So it's kind of for you and Roberto. But it's got to do with Roberto's parking lots. So if I was the water resources engineer, I think I would prefer to have one parking lot between the buildings. It'd be easier to manage stormwater from one parking lot than two. Did you guys talk about that, or?
We did talk about that, and He wanted to go with the 2 entrances. I'll just have to design 2 culverts that go under those
Okay,
entrances for the ditch system.
Ultimately, we felt that, I guess, the safety and ease of access was a much higher factor for the project than, say, having to design 1 extra culvert. So we went with the 2.
okay. Would one parking lot would that have reduced the impervious area at all, or would it have been about the same? The total like impervious area?
It likely would have been the same, considering the spacing of the 2 buildings would have required essentially the queue from the street to the assisted living or the senior living building is roughly the same length as it would have been to just add the connection to the senior living from the commercial building parking lot. So,
The parking lot sizing won't affect my calculations as much as the building size change.
Okay,
I'm pretty sure the building got a little smaller, so that will definitely change my area by quite a bit.
okay. And then for Ryan, do you know what are you going to use for your check dams? Because, well, go ahead.
There'll be vegetated check dams.
Like little mounds of dirt with vegetation on them, or?
Yes.
Okay. I guess just some comments about that. So, I mean, it could be a driving hazard, right, if a car goes off the road. So you might want to talk to the transportation people.
We could have that discussion at some point. That's a good point. I didn't really think about that, but that is a good point.
And then oftentimes those check dams are somewhat permeable. So that water can still move down the ditch, but it permeates through that material. So I don't know how permeable soil you're thinking about using, but
Okay. The goal is to make it so that it will transport the water to the rain gardens and
Okay.
detention ponds, so.
okay.
So a couple questions, maybe on the water resources side. Let's get the microphone. Can you, I guess, explain to me the difference of how the rain gardens are going to perform in, let's say, just a normal rain event, and if there was a severe or a high-level rain event?
So the rain gardens will hopefully serve the site most of the time. In case of a 100-year storm, there will be overflow to the detention pond. So in normal rain events that aren't very large, most of the water will just infiltrate into the rain gardens.
And so you'll use like 100-year?
Correct.
Thank you. And then on the transportation side for aid, where you have your costs and you have your alternative going across basically the swamp, like the wetland, right? Is that reflected in the numbers as far as NDOT, as to you're not going to have...
Like the final design slide are you talking about, or?
Yeah, so you were mentioning the cost and using
I shut it off.
NDOT numbers, but the soil, like in that area, right, and the water level and things like that, will likely make construction much more difficult, I would think. And so whether that's reflected in the numbers.
So, okay, what portion of this are you talking about?
The one that's going right through the wet part of it, right? Going
Okay.
across the creek and into that area.
So the most
Yeah,
northern region
the
of it? Okay. I guess what was the question regarding it?
So the NDOT cost that you pulled, was it like for just a typical road, a typical bed, like kind of construction? Or would it include the fact that you're going over very poor soil, right? Very...
Where the majority of the cost came from for that is from the excavation. So like there's trees, there's timber there. There's also a little bit of right of way. So that all factored into that.
But anything like about like the building the road itself, like the bed of the road or things like
Right,
that?
right, yeah. There is, because there is a riverbed, the soil is silty, so there will need to be replacement soil added to it, more clay, to add more structural to it. make it more dense. That way the road will not sink in and for freeze thaw purposes. But yeah.
Do you think that's reflected in the cost?
Right, yeah, that's in the miscellaneous items. So that's like with pavement markings. I have a whole spreadsheet with all of that, based off the NDOT requirements, of their price material base. But yes, yeah, it's reflected in there.
Thank you.
Any more questions? Okay, thanks.